We've got universities. I love your CAD idea, the BIM idea. That's the one. Because I think this is definitely where I think kids, and it goes back to your university thing. How do they learn skills, right?
Yeah.
So I want to blend all of them into one for a second. We're out there getting badges on LinkedIn. We're trying to figure out if we should go to university. We want real world skills, but the addiction factor, anything from Epic, Fortnite, skins, things like that. If you could actually put some actual real Newtonian engineering, game over.
You know, I
you would
actually
have
think
a whole generation of people building, because especially you could build a tool, right? Like you could, like SolidWorks is one thing, but like you could actually, and now you just jack it into the printers and things. People will actually start optimizing utility tools, because it's not just
the thing is, if you start,
anything.
if you look at what happens with kids, they start with Minecraft on an iPad, but then they get onto a Mac or a PC where they can run mods. And the mods are like the starter drug for coding, right? So they're basically leveling up to a more advanced version of Minecraft, and that becomes how kids learn to code these days, because they just want to write code to make their Minecraft shit work. So they do it as part of the game. So then what we should do is like craft a next level and a next level, where the next level up from there is Newtonian physics, and you end up in SolidWorks, or you end up in NVIDIA's world model. I forgot what they call it. But you end up in an actual industrial grade environment, but you're starting from Minecraft,
that's where
but
you
you're
put the
going
rewards.
all the way up. The other way.
Put the rewards. Imagine if you can get your Minecraft item, I put this in inverted commas, and then suddenly it becomes, we'll print it for you. We'll use the coffee grounds. We'll print it.
I remember people, there was like a little wave of people trying to hire folks who had experience leading quests in World of Warcraft, because it was a very realistic teamwork, social environment. The people who could lead those teams on quests ended up being useful hires, right? And so I think there's versions of this where it maps back to your LinkedIn profile, right? You play Minecraft.
And it goes back to your teams. No, this is, I think you may have unified your question about education, LinkedIn, team survival, and
when you die, we make a diamond. That's the ultimate badge.
Yeah, that's the badge. Because imagine, think of it. You go from Lego to like erector sets to rope, whatever they call it. I don't know. They have all these different things that we used to play with as kids. And you started like giant blocks. But at the end of the day, as if tools are the human's evolutionary advantage, this could be a great stepping stone. And if you think about it, there's going to be challenges, right? You're not going to know Newtonian load. You're not going to understand like how many gigapascals something's using. You won't know these things, but you will. If you have to get higher, you'll learn it. You'll research it. You'll be like, oh, you don't know why your bridge keeps breaking? Here you go. Learn a course on
Forget the course. You could learn it in Minecraft. So I keep building bridges, they fall down.
Sorry, I'm not saying you have to go out. You learn it in Worldcraft, whatever we want to call this thing. Worldcraft?
Yeah,
should we just rip off the name?
Yeah, maybe.
Get sued immediately by Microsoft. Anyway, I just thought that was a good wrapper to it, because it does unify most, except for the diamonds, but it does unify most of this series of things.
Yeah, and we're getting there.
I like it.
Interesting.
We should think about that. I actually think I know some folks.
Here's what I think we'll do. We'll do a short series on building the Young Ladies Illustrated primer, which is...
Oh, I like it. And little Neil Stevenson.
Yeah, and because what we're talking about is it's got elements of metaverse, it's got elements of primer, it's got elements from World of Warcraft and Minecraft and all the other crafts. And so we have all the puzzle pieces now. What we didn't have 5 or 10 years ago, even 5 years ago, was all the puzzle pieces to make this all work. But now we have the physics engines. Now we have the LLMs.
Computation.
We have a surplus of computation. So now we can actually tile this together. We just need to get a good vision for it. So maybe what we could do is have a short
Maybe this is one that you and I should work on.
Yeah.
I'm actually good with this one.
Yeah.
This one is a good, quiet you and I project. We can let people in on it and they can help us contribute. We make it a bit open.
Yeah.
But I actually think this is a big enough thing, because
it's huge.
Look, in '95, we tried through our computation system to build some sort of, back then for the MUDs, I think MUDs, pre-World of Warcraft, some multi-user dungeon, going back to D&D.
Yeah.
You had MUDs called multi-user dungeons. We were trying to figure out, how do you do Newtonian physics? Could we compute fast enough the bouncing of a ball?
Right.
And you would think you could, but no, you run out really quickly. Like really quickly run out of computations.
Yeah.
It just goes out the door. Otherwise, But given that we've been trying to simulate nuclear explosions for a long time, we've gotten pretty good.
Yeah.
And if we can do our computational fluid dynamics and the rest of it in a really interesting way, you'll find out if your skyscraper bends, right? You'll be able to do some really cool things. Shit, someone's going to come up with weather at that point.
No, I think we're getting close
all the way there, but it'll be really cool.
We're getting close, much closer.
We're getting close.
Weather and neurons and all the things we couldn't model before. NVIDIA is shipping
We're close.
NVIDIA is shipping an exaflop in a cabinet.
Yeah, it's insane.
Yeah,
insane.
It's totally.
I don't know if everyone understands what you just said, but I remember when there used to be the race to a teraflop.
No, let's start this from scratch. So if we do a little napkin math on NVIDIA, you add up all of the supercomputers in the world right now, you get about 6 exaflops total. Now there's more than that in pockets, right? So if you add up all the iPhones, you got a lot of exaflops there, but they're not connected. Like they can't build models. They can't do stuff that supercomputers can do. 6 exaflops total. What NVIDIA showed in their last keynote last month is they're shipping an exaflop in a cabinet. So a cabinet the size of a refrigerator. So this year, we will go from an exaflop world to a zettaflop world. And nobody has any idea what that means. That's why NVIDIA is saying we can make these huge computational models of the world of physics, because it's enough computation that the things that were laughable before, like modeling climate, modeling all the neurons in your brain, modeling every cell in your body, all of that was impractical before. That
by the way, this is pre-quantum. So when
fuck
Google
quantum.
said quantum supremacy, fuck them. Exactly.
Yeah.
When they said quantum supremacy, NVIDIA just
exactly. Quantum supremacy is a joke right now. Meanwhile, conventional computation is just blowing everything away. And that's why I said Moore's law, we thought of it as this amazing exponential growth curve. Moore's law was a fucking handicap. It was Intel's roadmap. It was holding us back because it was keeping us from developing all these other ways of making computers faster. And now that lithography's maxed out with extreme UV, we can't keep doubling transistor density. So we finally get to fund all these other ways of making computers faster. That's what NVIDIA is doing. New chip architectures, new algorithms, new ways of making backplanes, new ways of connecting these silicon
It's like fully recursive, right? That they just take their own chips to make their own chips.
Yeah.
Like now almost every path is like recursing. It's like, all right, little exaflop cabinet. If you don't make a little zettaflop cabinet, I'm going to cancel you.
Yeah.
His robots are being roboted. It's really nuts. I remember when he said that, I wondered if everyone got both like a chill and the goosebumps at the same time. I heard
that moment when I saw that, I was like,
that was a moment.
Holy shit, nobody on earth is paying attention to what matters right now. Wars in the Middle East don't fucking matter. None of that's going to matter.
That was the moment, right?
The future of the world hinges entirely on this fact.
That was the moment. And that moment, I think we got to give that a shout because I don't think people understood. I remember all of your tracing, routing algorithms for chip routing and all the bullshit that we used to do. Just think of Cadence and like all those guys who were playing with for right. He literally said in one sentence, oh, and by the way, I forced my chips to make a chip. I was like, what?
Yep.
Wait a minute.
It's just
I'll fire that chip if he doesn't do it. If this little group of chips can't make a better chip, he just created computer evolution.
Yeah,
chip
I think
evolution
that's in a way
is what he created.
In a way,
that's basically what's going on. And that recursion, that insane recursion, is not Moore's law. I think that's going to be the new law. That law, whatever you want to call, whatever the hell that was, because that's not exponential in like an order of every 18-month bullshit. This is messed up levels. And I was thinking to myself,
and what's cool about it is it's happening in a way that's different than what people thought. People thought the Kurzweilian version of, the computer is going to get so smart that it can make itself better was going to end up being in the AI algorithms and software side. We're not actually witnessing that yet, but it is happening in the chip design side and in the growth of computation. And call it Jensen's law. I'm cool with that.
Yeah. Jensen's law. I think we should give him the first. I'm telling you, it is absolutely wild. I don't even know if anyone's done the math on what that looks like because we don't know how many little cabinets of exaflops.
I mean, it's thousands.
But you can only imagine that of whatever chip output they've got,
Yeah.
he's probably reserving like 10, 20% just for his shit.
I don't know.
No, this is it.
No,
This
he
is the
could.
question.
He
What is
should.
the
And
true?
yeah, I think you're right. I think he becomes the next AWS. He becomes the AWS of AI or something. It's insane what's possible here. I think the interesting thing is, like, the reason I said this is the only thing that matters is I have a computation-centric worldview, right? And what I think is the only thing that matters is how you pin your view on the point of diminishing returns of computation. That's what matters. If you decide at what point does more computation not make the world better, do you think that we passed that already, or do you think that is at exaflops? Do you think it's at zettaflops? Do you think it's at heliflops? At what point does adding computation not keep helping make the world better? And I'm a computation maximalist, so I think that we keep going and that we're still just at the very beginning. And so what this means is that NVIDIA has gotten us to a point where we get to make the next big leap. So I think it doesn't fucking matter who becomes president. They're going to win because they inherited a zettaflop world, right? In the same way that, like, you could say, Trump got fucked because he inherited COVID, tanked his thing. Never mind Trump. The point being, you could say these geopolitical global factors that matter, and the one that matters the most is zettaflop. It's not global warming. It's not wars in Ukraine. It's not German
You're right. I'm
energy
with you
policy.
because
Yeah.
here's the interesting take, and this is why I'm really strongly suggesting that we work on that other project, because I think if you set the rules, sorry, not the rules, the non-rules of the game, that's a world game.
Yeah.
That world game lets us map out good and bad things with speed of iteration without damage to the real world.
Yes.
Right? So you don't have to have global warming. You're going to see your game get globally warmed.
That's right.
Or you're going to see these things really fast.
That's
so
right.
Here happens. Kids start to play in a real simulation, simultaneous existence, but there's an output vector. I don't want to give all this away, but I think there's a way to do this so that you create this symbiotic loop. And that symbiotic loop structure becomes extremely exciting. Now, you're not sitting there with like LLMs and like all this like superstition thing that we talked about previously. Now what you've done is built an iteration framework. With an iteration framework, forget it. Like, we're on it. Like, we still maintain human control. We're just turbocharged. Like, we're on Adderall sprinkled with cocaine, then free-based, right?
Yeah.
It's like we're on all three versions of a stimulant.
Yeah. And I think that you end up in a situation where in your world game, it's generative. So everyone's wound up about generative AI, but what you would do is you would generate the world, you would generate the things in it, you would run simulations. Each game, a game is a simulation. Like, you say, okay, what happens if we do X, Y, or Z? And each of those gets funded by the players. The players say, okay, we want to run a simulation on what happens if things get warmer. What happens if we make these interventions that keep things from getting warmer? What happens if we deploy nuclear reactors?
One you let it happen normally, and then the other one you hit the button and says accelerate.
Yeah, right.
And that's what you need your zettaflops plus.
Yep, there you go.
And if you go to the accelerate portion, then it becomes really cool.
Yeah.